In this problem, I need to find the critical value or values for testing the claim that P is equal to 3/5. The first thing I'm going to do is write down the null and alternative hypotheses. So my null hypothesis is that P is equal to 3/5. The alternative hypothesis is that P is not equal to 3/5. And it's really the alternative hypothesis that I'm primarily interested in here, because this tells me that we're going to do a two-tail test. So if it's not equal to, it's a two-tail test. If it was a less than statement, it would be a left tail test. And if it was P is greater than 3/5, it would be a right tail test. And the reason I know that it has to be a two-tail test and that the alternative hypothesis has to be that P is not equal to 3/5 is because when I look at the claim that says that P equals 3/5, there's no indication of greater than or less than. So we always have to go with the two-tail test in those cases. Okay, so now I draw my normal distribution, and I've set this up as a two-tail test, so I've shaded in each of the tails. And now we need to find what the critical values are. So alpha is 0.05, that's our significance level in this problem. So alpha is the total area in the two tails, which means that one tail has to be 0.05 divided by 2, and that's going to be 0.025. So our critical values are going to be plus and minus z sub 0.025. So how do I find those critical values? I'm going to use the inverse norm function from the calculator. And because the 0.025 is on the right-hand side, I'm using 1 minus 0.025 here. I could have used 0.025. I would have gotten a negative value. Doesn't really matter because I want my two critical values, which are plus and minus 1.96. So I'm going to go ahead and fill that in my distribution. And now we're going to take a look at our test statistic. So our test statistic is z equals negative 2.63. So I'm going to locate that on my distribution, and we can see that that value is falling in the left-hand tail. Now the tail areas, we also call those the rejection regions, because that's where if the sample information falls into those rejection regions, that means that we're going to reject the null hypothesis. So the next part asks, should we reject the null hypothesis or fail to reject the null hypothesis? And we are going to reject the null hypothesis because the sample information is falling in the tail. It's falling far away from the center. So we don't believe the null hypothesis that P is equal to 3/5. The sample information indicates that P is not equal to 3/5. And that's how you do that problem.